Hello everyone, welcome to the Reliability Insider channel. Have you ever finished the reliability data analysis, but still not sure what maintenance action to take? Should you optimize maintenance time, investigate the design, or simply keep monitoring? In this video, I will show you how to make better maintenance decisions with Weibull and Crow-AMSAA results. To make the right maintenance decision, let's first review what information each model provides. Although both models use reliability data, they answer two very different maintenance questions. Crow-AMSAA focuses on the reliability trend. It tells us whether reliability is improving or getting worse over time, which helps us evaluate whether our current maintenance or corrective actions are working. And Weibull looks at the failure behavior. It tells us whether failures are wearing out and helps us to determine whether preventive maintenance is appropriate and when it should be performed. Each model provides valuable information, but neither of them tells the whole story. You need both to make the right decision. Now let's combine them into the maintenance decision framework. Here, the horizontal axis represents Weibull beta, telling us whether wear out exists. And the vertical axis represents the Crow-AMSAA beta, showing reliability trend over time. Let's start with the bottom right quadrant. Here, Weibull tells us that the failures are wearing out, meaning that the failure risk increases as the equipment ages. In this situation, preventive maintenance can effectively reduce failures. At the same time, Crow-AMSAA shows that the reliability is improving, indicating that the current maintenance strategy is working. So here the next step is to optimize the maintenance interval or move toward predictive maintenance if reliable conditioning monitoring is available. And then let's take a look at the bottom left quadrant. Here the failures are random or occur in early life. Replacing those components on the schedule is unlikely to reduce failures. At the same time, since reliability is already improving, continued monitoring and a run-to-fail strategy is usually sufficient. Now let's look at the top left quadrant. Failures are primarily early or random, so preventive maintenance is unlikely to reduce them. At the same time, reliability continues to worsen, indicating that the current approach is not enough to solve the underlying problem. Instead of adding more maintenance, start with root cause analysis, and then improve the processes, supplier quality, manufacturing, or other assignable causes identified during the investigation. And finally, let's look at the top right quadrant. Failures become more likely as the equipment ages, so preventive maintenance is necessary. However, reliability continues to get worse over time, indicating that the existing maintenance alone is no longer enough. At this time, you should start by optimizing your maintenance strategy to reduce failures in the short term, while in longer term, investigate the root cause and implement design improvements to eliminate the underlying problem. This framework doesn't replace engineering judgment, but it provides a practical starting point for choosing the right maintenance strategy. Let's apply this framework into a real example. For this pump population, the Weibull analysis gives a beta of 3, indicating a clear wear-out mechanism. The Crow-AMSAA beta is 1.5, showing that the reliability continues to get worse over time. Together, these results place the population into the upper right quadrant, where preventive maintenance with part replacement is necessary because wear-out is present. However, the maintenance alone is not sufficient to solve the problem. The first step is to understand the root cause and investigate the underlying failure mechanism and improve the design. During the investigation, you may focus on the mechanical structure, component selection, material choice, or other operating conditions. Here is the key takeaway message. Do not rely on a single reliability model. Use Weibull to understand the failure mechanism and use Crow-AMSAA to understand the reliability trend, and combine them to choose the right maintenance action. Thank you for watching. If you'd like to learn more, my new course on turning reliability data into maintenance decisions is now available. If you find this video helpful, please subscribe for more practical reliability insights.